Okay, ladies and gentlemen, let's finish off example 3 and example 4. Alright, so for each question, factor using the most appropriate method, and they're going to want us to remember that we need what type of factoring there are. There's trinomial factoring, and there's difference of squares factoring, and there's common factoring, and we always try to do common factoring first. Looking at this, I notice that there's 3 terms, so I'm thinking trinomial factoring. I'm looking at the number in front of the x squared. I notice that it's not a 1, so it would be seesaw. But before I do that, I always try to common factor first. I take a look, and I've got a 3, a 6, and a 15. Common factoring will work. I can take a 3 out of all of them, and that will leave me with 3 equals x, or 3 times x squared plus 2x minus 5. Notice if I put it back in, I get 3x squared, 6x negative 15. I notice I've been left with a trinomial. I'm going to try to factor that. I'm going to look for 2 numbers that will give me a product. Now it's just the trinomial that I'm factoring, so the 3 doesn't count at this point. There's a equals 1 here, so they're going to have to give me a product of negative 5. And they're going to have to give me a sum of 2. Well, the only numbers that'll give me a product of 5 is 1 and 5, and there's absolutely no way that'll sum to give me 2. What does that mean? It means that this does not factor. This trinomial will not factor into 2 binomials. That's fine. There's lots and lots of trinomials out there that don't factor, and you need to be able to tell me when it happens. So what did we do here? We did common factoring, and we notice that this trinomial does not factor. So I would give 2 marks for this, 1 or maybe even 3. 1 mark for the common factoring, and 2 marks for telling me that it doesn't factor. And you know it doesn't factor because we did the product, the factor tree. There was the only ones that would for products is 1 and 5, and there's no way that they can go together to give a sum of 2, so we know that this trinomial does not factor. All right, let's look at the next one. B. Okay, so 3v squared plus 5v minus 2. I'm looking at it, and it is a trinomial, and I notice that the a value is not 1. So I try to common factor first. A 3 and a 5 and a 2. Nothing will common factor out of there. So if this factors, it's going to be a seesaw, trinomial factoring. So I'm going to put a 3v and a 3v over top of a 3. And I'm going to try to find a product of 3 times negative 2, which is negative 6, and a sum of 5. Let's see, so 1 and 6 and 2 and 3. Now this gets tricky because both 1 and 6 and 2 and 3 will go to give 5. However, only one of them will work. Let's see, for me to get a positive 5, I could have a negative 1 and a positive 6, and then they would add together to give me positive 5. I got it. Notice anything else wouldn't work. If I tried to do it with the 2 and the 3, and if I was trying to get the negative 6, one of these would have to be negative, and it wouldn't sum to give me positive 5. So, off I go. I got 3v minus 1. I got 3v plus 6 all over top of 3. So, I actually goofed up what I was doing here. I should have put these numbers up here, so I didn't. So what I'll do is I'll just get rid of that, and I have this here now. What I need to do is be able to get rid of the 3 on the bottom. Remember how we do that? We look to common factor out of the top. There's nothing to common factor out of the first binomial. However, the second binomial, I can take a 3 out, leaving me with v plus 2. So now I've got a 3 on the top, I've got the 3 on the bottom. They will reduce, leaving me with 3v minus 1, v plus 2. Take a look, see if anything will factor any farther, and it won't. Let's check it. 3v times v is 3v squared. 3v times 2 is 6v. Take away 1v is a 5v. Minus 2, it works. Okay, next one. Okay, 3 terms. I'm thinking about trinomial factoring. I see a 2 in the front. Thinking seesaw, but I always remember to common factor first if I can. And I can take a 2 out of everything. So a 2 comes out. So that was nice. So we common factor first, always. Now I'm looking for 2 numbers that will multiply to give 24. So I'm looking for a product of 24 and a sum of 11. Well, 24 is 1 and 24, 2 and 12, but it's also 3 and 8. And 3 and 8 go together to give me 11. So I got to keep the 2, don't forget about it. But we factored that trinomial. And it was a h, an h, plus 3, and plus 8. Now don't forget to bring this 2 down. You need all 3 factors to multiply to give you this. And check these out. There's nothing else that'll common factor out of them. They're not differences of squares. I'm good to go. The last one's a bit of a tricky one. It's a little bit unfortunate. What if we were to look at it like this? Let a equal x squared. If I was to say let a equals x squared, then you would notice that x to the 4 is x squared squared. You would notice that negative 8x squared plus 16. So if I let a equals x squared, I can go and replace each of the x squareds with an a. And what I would get is an a. Here's an x squared, so it would be 8a plus 16. So actually, I come up with a trinomial in terms of a rather than x squared. This can be factored. This will be a minus 4 and a minus 4. Those are 2 numbers that multiply to give 16 and add to give negative 8. And if we remember that a is x squared, so you put x squared back in for a, we get x squared minus 4, x squared minus 4. Now, that would be good. We could write it like this. X squared minus 4 squared. And that would be fine. This could go farther. This is a difference of squares. We could come up with this. X minus 2, x minus 2, all squared. And then we get x minus 2 squared, all squared, which is x minus 2 to the 4. Now that's getting a little ridiculous. I would be happy if you stopped here. But again, this is a trick type. I'm not interested in it. I showed it to you because it was on the page. You're not going to see this again. You won't see this again. We will see these though, so we need to keep our eyes open for those. Let's see what the last example has in store for us. Example 4. All right, let's finish these 2 off. Apply factoring to analyze the quadratic functions. Show that the vertex of the function x squared minus 4x plus 4 lies on the x-axis. Well, this is in standard form. I think what I would like to do is I would like to change it to factored form. So I'm looking for 2 numbers that'll multiply to give 4 and add to give negative 4. So that'll be x minus 2 and x minus 2. So I factored this using my factoring techniques. This will become x minus 2 squared. Now, notice that this was in standard form. And this I've now put in vertex form. And in between, we had factored form. So that's kind of cool. I went from standard form to factored form to vertex form. Now, what can I tell from vertex form? Well, this vertex form looks like this usually, right? It's usually a x minus h squared plus k, where the vertex is going to be at h comma k. So for this one, our k value is 0 and our h value is 2. So we have a vertex at 2 comma 0, which means that if my y value is 0, then it lies on the x-axis. So 2 comma 0 is where my vertex is. And I found it by taking a standard form, converting it into factored form, and noticing that it was a perfect square trinomial, which means that it can be written into vertex form. Cool. I like that. All right. Show that the function y equals x squared minus 9 is symmetrical about the y-axis. Symmetrical means that it's a mirror image on either side of the y-axis. Well, okay. I think what I'm going to want to do for this one is factor. So I've got x squared minus 9. This is a difference of squares. It's going to be x minus 3, x plus 3. What does that mean? Well, we know where the zeros are, or the x-intercepts. The x-intercepts are at 3 comma 0 and negative 3 comma 0, which means they're here and here, which means that the vertex is going to lie directly here, 0 comma negative 9. I saw that up here. So this has a vertex of 0 comma negative 9. So again, in h, if I think about it in this form, the h value is 0 because it's just x squared, but my k value is negative 9. Or you could consider this standard form, and this is my c value. It doesn't matter. It all works. But in any case, because I have my x-intercepts on either side an equal distance from the y-axis, what that shows is that this is symmetric about the y-axis. Meaning that whatever's on this side of the y-axis is mirror imaged on that side of the y-axis. And I think it goes without saying that here's your y-axis, right? So that's how that works. Okay, ladies and gentlemen, I'm going to post some homework for you. I want you to work on it. Make sure that you're able to do it because you will be assessed on it. And I'll be back to see you in a couple of days. Make sure that you're checking your LMS daily and that you're checking your board email. And we'll talk soon.